Hello, chemists. Today what I'd like to do is give you an overview of the lab that we're going to be conducting this week on kinetics. Specifically, we're going to be using a purple biological stain called crystal violet that's a very, very dilute concentration. And we're going to be reacting it with 0.10 molar and 0.20 molar sodium hydroxide. The big picture idea is that when you combine these chemicals, at first you will have a purple, it will be purple in color. As the reaction proceeds, it will eventually go to a clear solution. So we're going to be using a vernier colorimeter which will shine light through our solution, and by shining the light through our solution, it will be able to graph absorbance versus time, and the absorbance is directly related to our concentration. So essentially we'll be looking at concentration versus time. Then we'll take that data and graph concentration versus time, the natural log of concentration versus time, and 1 over the concentration versus time to figure out if it's a 0th order, 1st order, or 2nd order reaction with respect to the crystal violet, since it's the more dilute chemical in this reaction. Okay, now before we can actually dive into the reaction, there's a few things that we have to go over and understand. One, this is called a cuvette, and it has ridges on one side and it's clear on the other side, and there is some water left in it from the previous reaction I did. You always want to touch it on the ridged side, because when you put it in the colorimeter, you're going to put it in the colorimeter with the clear sides. So you don't want to touch those because a fingerprint on that side could affect your data. The other thing we have to do is we have to calibrate this colorimeter before we actually use it to do our experiment. So I'm going to go ahead and go through that process right now. To calibrate it, I'm going to use just deionized water. So I'm going to fill it about 3/4 of the way with deionized water, and I did condition this with deionized water too before I started. If you're worried about getting smudges on it, or if you're worried about it being wet, you can always take like a chem wipe or a paper towel and kind of wipe it down before you start, just to make sure there's no fingerprints on the clear sides. So I'm going to go ahead and insert that into my colorimeter. And then we have this Lab Pro software that just is essentially an interface between the colorimeter and the TI calculators. And in order to calibrate it, we got to be very careful with our settings. So what we want to do essentially is turn on the TI calculator. We want to push the apps button, and then we want to pick the Chem Bio program. So that's how we want to start it, and that'll just start the vernier software, and then we hit enter to actually enter the software. So before we collect data, we want to set up our probes. So you want to hit either enter or 1, and that will select set up the probes. We have 1 probe, which is our colorimeter, so we hit 1 and then enter. And then they ask us what kind of probe we have. Well, we have a colorimeter, so I'm going to hit 4, and that'll select that. It says use the lowest available channel. So what that means is the colorimeter is actually plugged into channel 1 here. So then when it says enter channel number, I'm going to put 1 and hit enter. Now that we've selected the correct channel to allow the calculator to get data from the colorimeter, now we have to calibrate it. So I have a cuvette in here with filled 3/4 of the way with deionized water. And for our first point, what we want is essentially 0% transmittance, which we want to turn it to the 0% setting there. And then it will equate it to a certain voltage. And once this voltage is fairly stable, which it looks like it is, it tells us to push the plus sign. So I'm going to go ahead and push the plus sign. Now they want to know what reference is it. Well, this is our 0% transmittance, so we type in 0 and we hit enter, and that will give it the first data point. Now we need the 100% transmittance value, so essentially the range, and so for that we need to change our setting from the 0% up until green, which is the wavelength that we're going to be using for the crystal violet, because it's a complementary color to purple, and it will absorb, while the solution is purple, it will absorb the most amount compared to other wavelengths. Okay, so now that we've got it set at green, which is our second data point, and now that it's stabilized at roughly around 2.800, we hit plus, and then they want our reference for this. Well, this is 100% transmission, so we type in 100 and hit enter, and then now you can see that it essentially has both a 0% and 100% transmission value. And then now we can hit enter and our calibration is complete. Now it brings us back to the main menu, and now we are ready to set up our data collection. So I'm going to go ahead and push 2 for collect data. I'm going to also flip over my procedure because I'm following it as I go. Okay, so they tell us we want a time graph, which is option 2. So I'm going to select that. They tell us the time between samples is 4 seconds, so it will collect data every 4 seconds, and then you hit enter. The number of samples we want is 45, and that will essentially sample it for 3 minutes is what it ends up being. And then now they tell us the experiment length is 180 seconds, which is 3 minutes. That looks good based on our sample data. And then we press enter because all that looks good. And we want to use our time setup, so we're going to press 1. Now, they tell us for the values here, our minimum absorbance is going to be 0, so you want to push 0 and enter. Our maximum is going to be 0.5, and then we hit enter. And our Y scale is going to be 0.1, and then we hit enter. All right, at this point, we have done all the work necessary to get the calculator set up to run the experiment. Now right now I still have the distilled water in here, and now's the point where we need to pause, mix our chemicals, and we want to work pretty quickly because the reaction is going to happen as soon as we mix our chemicals. So I'm going to go ahead and open my colorimeter, carefully take out my cuvette touching the ridge sides, and I'm going to go ahead and, since this is distilled water, I'm just going to go ahead and dump it in the sink. Now just to explain what I'm going to do next, because I'm going to do it very quickly, I have 5 milliliter amounts of both the crystal violet and the 0.20 molar sodium hydroxide already pipetted out. I'm going to combine those in a beaker, mix them up quickly and swirl them with a pipette, and then I'm going to fill my cuvette about halfway with the mixture just to rinse out any residual deionized water and put it in the waste. So that's a process called conditioning, when you just, you want to make sure that there's no residual chemicals or contaminants in your graduated cylinder or cuvette before you start your experiment. And then after I do that, I'm going to very quickly fill up my cuvette about 3/4 of the way with the crystal violet sodium hydroxide combination, put it back into my colorimeter, close it up, and then hit enter so that I can start collecting my data for the kinetics reaction. So that's what I'm going to do right now. I'm going to go ahead and pour my crystal violet in, and then I'm going to pour my sodium hydroxide in. And you can see right now it's still a purplish looking solution. Over time it will become clear, and that's what should happen. So right now I'm just conditioning it. I'm trying to squirt it on all the sides with the crystal violet solution just to make sure the cuvette is clear, is clean. All right, then now what I'm going to do is fill it about 3/4 of the way with our reaction mixture. That looks good. And I think I actually touched the clear parts. So I'm going to very quickly wipe it down just to make sure that there's no fingerprints. Close it up and hit enter. And then now I can start my data collection. And you'll see that what the TI calculators do as they're doing the data collection is they just kind of give you a graph, and you can see like little dots in the bottom left as it's sampling. And again, it's sampling at every 4 seconds. So we won't really see a tremendous amount of information until after the experiment is over, after 3 minutes. But if you look back at our beaker with our combination of crystal violet and sodium hydroxide, you can see how it's considerably more clear now than it was when we started. And let me see if I can get, I'm just gonna put, yeah, you can see now it's getting clearer and clearer as it goes on. And that's why it's kind of important to work quickly because, as the reaction proceeds, it will will eventually get to a colorless position. Okay. All right, now that the 3 minutes is complete, this is what your calculator will look like. So what it's letting you know is the time values that it collected, which is the sampling every 4 seconds, is in L1, and then the transmittance values, time is in L1, absorbance is in L2, and transmittance is in L3. So if we hit enter, there's a graph of our absorbance versus time graph. And since absorbance is directly proportional to concentration, if it was a 0th order reaction, then the absorbance versus time graph would be linear, which it's not. So that immediately lets us know that this reaction can't be 0th order. Now, if I, let's see, if I quit out of this, no, how do I do this? Okay, repeat, I'm gonna say 1 no, and I wanna actually look at my data. So I'm gonna actually do 7 and quit out of this ChemBio program. And then I'm going to go to Stat, Edit, and you can see what it's done is the time is in L1, and it should be like 0, 4, 8, 12, all the way up to our 180 seconds. L2 is our absorbance values, and L3 is our transmittance values. Now what we need to do in order to graph all the graphs and figure it out, remember 0th order is concentration versus time, so that's our L2 and our L1. For L4 though, we need to do the natural log of our concentration because that's, a graph of the natural log versus time is, is 1st order if it's linear. So what you do is you go up, highlight the L4, type in LN, and you can see down here it's typing it in, and then you want to do alpha 2, or excuse me, second 2, and that will tell us L2. So what essentially what's going to happen is going to take all the data in L2 and take the natural log of it, and then populate it in L4. Okay, and then last but not least, for L5, we know with a 2nd order reaction, 1 over the concentration compared to the time is going to be linear. So here we're going to do 1 divided by, and again, second 2, which is L2, and hit enter, and then it'll immediately take all of our L2 data and divide it by 2. Okay, now we have all the data in here. Now we need to plot it. To plot it, what we're going to do is go to stat plot. Oops, excuse me, I went to y equals. We'll just go ahead and clear these values. Okay, so I need to go second y equals. And right now, plot 1 is on. If we check that out, it is getting the x value from L1, which is our time, the y value from L2, which is our concentration. So all that looks good. So now if we hit graph, that's graphing our absorbance versus time, and we can tell it's not linear. So next we go back to stat plot. I'm going to turn this plot off, and then I'm going to go to plot 2, and for plot 2 I'm going to turn it on. And now what I want to do is my time is still in L1, but now my natural log of time, or excuse me, natural log of concentration is going to be in L4. So we're going to type second 4, and that'll give us L4. And I'm going to go ahead and just pick this dot as a mark because it's smaller, so it'll be easier to see. Then we hit graph. It's not working because our window's messed up. So what I need to do is I need to quit out of this. I need to go back to my data. So I'm going to go to Stat, Edit, and I need to go over to L4 and see what my ranges are. So it looks like it's going from like -3 point something up to let's see here, -5 point something. So we need to change our window to reflect that. Okay, so to do that, I'm going to go to Window. My X-Men, X is our time, so I'm going to say I'm going to go from 0 to 200. And that'll be a little bit more than we need. For our Y, I said it was, the lowest was like -5 point something, so I'm going to say -6 to a max of -3. And that should cover all the values for the plot that we're looking at right now. Now if we graph it, you can see it actually shows up on our window, and it's better, but I still don't know that I would call that linear. Let's check, if this was linear, it would be first order with respect to the reaction. Okay, so now we'll go back to stat plot. I'm going to turn the second plot off, which is the first order reaction, and now I'm going to go to plot 3. We'll turn that on. We've got L1. Now our 1/over concentration data is in L5, so I'm going to do second 5 to get it, to tell it to go to L5, and again I'm just going to do the smallest mark. Now again, we really need to check our data and check our window. So I'm going to quit out of this. I'm going to go Stat, Edit. I'm going to go over to my L5 data, and you can see the values here are very different. So we've got 29 up to 187. So I'm going to go like 28 to 200, and that should cover it for our Y values. Okay, so I'm going to do window. My X is still fine because it's still time. But now I'm going to go 28 is my min, 200 is my max, and then we'll go ahead and graph it. And then this is the data that we get, if this reaction is second order with respect to the concentration of crystal violet. So I'm going to let you look at those graphs, and I'll let you decide what you think based on those graphs. I will also upload all this information on, on Classroom and share it with you too. Thanks.